Assalamualaikum viewers. The topic of today's video is molecular dynamics simulations. So this is the last video in the methods of computational chemistry. So this is the last video in a series of videos where I have described the different types of method, the different modelings used in computational chemistry, like that of DFT, density functional theory, like that of ab initio, semi-empirical, etc. Okay, so now today in this video I'm going to focus on molecular dynamics simulation and I'll tell you what they actually are. So first of all, molecular dynamics calculations apply the laws of motion to the molecule. So what we do basically in molecular dynamics simulation, we apply the laws of motion of the molecule. But first of all, you need to know what really is molecular dynamics simulation. So molecular means related to the molecule and dynamics mean related to the motion, and simulations are actually the graphical representation through a computer program. So what do we basically do in molecular dynamics simulation? We just represent a chemical reaction, okay? We just represent a chemical reaction using a computer program. We represent how atoms will react together, how a reaction takes place actually at the atomic level. So we do basically all of these things in molecular dynamics simulation. So as you can see here, that molecular dynamics simulation, it involves the motion of the molecule. It involves the motion of the two atoms that are approaching each other to react. Okay, it involves the basic concept. So as you can see here, that molecular dynamics calculations apply the laws of motion to the molecule. So molecular dynamics calculation apply the laws of motion to the molecule because as you can see, the molecular dynamics mean the motion of the molecule as the name indicates. So the molecular dynamics calculation involves the laws of motion to the molecules. Okay. So here is an example of simulation where a copper atom is being attached on the surface of a copper crystal. Okay, so as you can see here, this is an example of molecular dynamics simulation in which a copper atom is attached on the surface of a copper crystal. Okay, so this is basically how we represent the model using the molecular dynamics simulation. Okay, so moving back. For example, if an enzyme acts on a substrate, the substrate attaches to the enzyme, the substrate attaches to the enzyme, and the enzyme changes its shape. Okay. So we can simulate this, we can represent it through the help of software. Okay. So the next thing I have is the motion of swarm of water molecules around a molecule of solute. So if I have a water in beaker and in that beaker I put a molecule of solute. Okay, so what will happen? The molecule of solute will be surrounded by the molecule of water. So I can represent this motion. I can represent the motion of the molecule that are coming around this solute particle through the help of the molecular dynamics simulation. Okay, so the molecular dynamics simulation basically represents how a reaction takes place, how some change take place at the molecular level. Okay, so quantum mechanical molecular dynamics also allows actual chemical reactions to be simulated. So using the quantum mechanical molecular dynamics, we can simulate the actual chemical reaction. Okay, so molecular dynamics is a computer simulation method for analyzing the physical movement of atoms and molecules. So using the molecular dynamics, we can actually analyze the motion, the physical movement of atoms and molecules during a reaction, during a process. Okay, so the atoms and molecules are allowed to interact for a fixed period of time, giving a view of the dynamic evolution of the system. So what we basically do in molecular dynamics, the atoms and molecules are allowed to interact for a fixed period of time. Okay, these atoms and molecules are represented through the software. Okay, and in that software the atoms and molecules are allowed to interact for a fixed period of time. Okay, giving a view of dynamic evolution of the system, means how a system changes with the evolution of time. Okay, so what we do in the software, we just allow the atoms and molecules to interact with each other and we just study how the system changes with the evolution of time. So in most common variant, the trajectories of atoms and molecules are determined by numerically solving Newton's equation of motion. So we can apply the Newton's equation of motion on this system. Okay, and the forces between the particles can be found by basic formulas. So the next thing we have, the method is applied mostly in chemical physics, material sciences and biophysics. So this was all about the molecular dynamics, and this was all about the 5 types of modeling, the 5 types of method used in computational chemistry. Okay, so that was all for today's video. Inshallah, see you in the next video. Do not forget to like the video and subscribe the channel. Allah Hafiz.